Welcome everybody to my classroom. Okay. Now I'm going to discuss about the topic group 16, the oxygen family. As you know, in the group 16 oxygen family, there are several several elements. Oxygen, sulfur, selenium, tellurium. This is not actually potassium, it's polonium. Okay. Oxygen having the atomic number of 8, sulfur having 16, selenium having 14, tellurium having 52, and polonium having 84. Okay, this is your oxygen family, group 16 or P block. Here we are going to discuss the electronic configuration of this group. As you know, the elements of group 16 have 6 electrons. What does it mean? It means the element of group 16 have 6 electrons in outermost shell. It means having 6 valence electron. Okay, valence electron is 6 because valence electron is the number of outermost shell consisting electrons. Okay, so it is number of valence electron. And I have the configuration of NH2 and NP4. General electronic configuration. Okay, what does it mean? Let's understand. Here there are some electronic configuration as you can see. Oxygen having the electronic configuration of 1s2, 2s2 and 2p4. You can assume 2s2 and 2p4 in last 2s2 and 2p4. Number of valence electron is 4 plus 2 6. It satisfied. Valence electron is 6, 2s2 and 2p4. Now it also satisfied the number of n. Here you can see the n. The value of n is here 2. It also satisfied ns2. Now here 2s2 and p4. There is 2p4. Now it satisfied these all things. If any element satisfies these all things, having 6 valence electron, in last having ns2 and np4 configuration, then this element resides in your p block element. This is like characteristics. If in examination someone asks what is the characteristics of the p block element, how can we decide any element in p block element, then you can see, you can write it as any element reside in p block element, if it having the 6 valence electron, 4 plus 2 6, and having ns2 np4 outermost shell configuration. Okay, now again in p block element 16 group, I am talking about the 16 group. Okay, not about whole p block element. Also for in sulfur you can see here 3s2 and 3p4, 3s2 and 3p4. What it indicates here, 3 is the number of n. Okay, ns2 and np4. Here 4s2 and 4p4. Here 4 is the number of n. 4s2 and 4p4. All having 4 plus 2 6 valence electron, 4 plus 2 6 valence electron. Here also 4 plus 2 6 valence electron, 5s2 and 5p4. It means it having 5 is the number of n. Also in last 6 is the number of n, 6s2 and 6p4. Either 6 is the number of n. Let's again assume it as here for oxygen Okay, the configuration starts as, because oxygen is actually your O having the O8. Okay, the configuration start at 1s2, 2s2, and the 2p4. Now it says this 2 and this 2 is actually the N, and it satisfies the condition N as 2 N P4. So this oxygen resides in the family of P block and having the group 16. I think it is clear. Now I'm going to talk about other things about the P block element 16 group. As you can see in the P block element, there are some elements like oxygen, sulfur, selenium, tellurium, and polonium. This is actually PO, okay, polonium. Oxygen having the atomic number of 8 as well as having the atomic mass of 16, 15.99. Sulfur having the atomic number of 16 as well as the atomic mass of 32 point something. Selenium having the actually atomic number of 34 and atomic mass is 28.96. Okay, this is not obvious. This is just an exception. As you can understand, if atomic mass is the number of nucleus, actually the atomic mass is the weight of nucleus, and weight of nucleus defined as the number of proton plus the number of neutron. You also understand one thing also, that the number of proton is always constant, it cannot increase and decrease because it is relative to electron, not in ionic case, but generally in neutral case it is relative to electron. Number of electron is always equal to the number of proton, not in ionic case, in general neutral case. Sometimes number of neutrons varies, number of neutrons increased, due to which the atomic mass changes. Let's understand it. If, as you can understand, if in sulfur there is, as you can see here, the sulfur having 34 as an atomic number and 78.96 as an atomic mass, you can assume in it is selenium. In it, you can assume selenium 34 is the atomic number of it, and as you can understand in the according to previous classes, number of proton is the number of is equals to the number of electron as well as it is equal to the number of neutron. But in a standard of 12th, it is not actually this equation. Number of proton is similar to the number of electron as well as similar to the number of neutron. It can vary. Electron and number of neutron can vary. Electron varies in the condition of ionization. If there is any charge, then the number of electron can vary. Also, the number of neutron can vary. Now, let's understand. In this, as you can see, 78 is the atomic mass. According to us, if the atomic mass is the number of P plus the number of N, and if these two are equal, then 34 plus 34 becomes 68, and it has to be the atomic mass, but it is not here. Here is 78. It means number of proton is 34 here, but the number of neutron is 44. It varies. It is not same. Now the atomic mass is different. Okay, this is actually the concept. Now we are going to talk about atomic and ionic radii. It says due to increase in number of cells, atomic and ionic radii increases from top to bottom in a group, and the size of oxygen atom is exceptionally small. What does it mean? Let's understand it. Let's understand. As we can see here, as we can see here, oxygen having the atomic number of 8, sulfur having the atomic number of 16, and selenium having the atomic number of 34. These three, if the atomic number increases, it is obvious that number of cells increases. And if number of cells increases, the atomic radii has to increase. What is atomic radii? Let's understand. Here, let's just assume this is oxygen having the atomic number of 8. Oxygen having atomic number actually 8. So having first orbit. In the first orbit, oxygen consists one electron here and one electron here. Also in second orbit, it consists one electron here, one here, one here, one here, one here, and one here, and one here, and one here. Now, let's just assume what is atomic radii. Here, this is your atomic radii. This is the value of R. This is your atomic radii, nucleus to the last orbit. Distance is your atomic radii. If we just consider the sulfur, which having the atomic number 16, now what happens? This is the nucleus, this is the first orbit, consisting one electron here and one here. This is the second orbit, consisting one here, 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 one here. 8 to 10, but we are still 16. Now still 6 is remaining. Again, a next orbit here. This 1, 2, 3, 4, 5, and 6. Now in this one, this is your atomic radii. This is the value of R. Now it is easy to understand. The value of R is less in oxygen, and the value of R is more in sulfur. It indicates if the atomic number increases, atomic radii increases. It, it is obvious, it is general. In this, atomic radii of oxygen is less, atomic radii of sulfur is more, atomic radii of cerium is more than sulfur, atomic radii of tellurium is more than cerium, atomic radii of polonium is more than tellurium. Okay. Now ionization enthalpy. As you can see, ionization enthalpy actually deals with the number of stability. Stability, what is it? Stability. Let's understand. Stability is nothing, just a thing that which compound or which element is stable, and we know that thing actually. In previous classes I have discussed that only those elements are stable which having the half-filled electronic configuration, a half-filled orbit in its last. See, half-filled, okay, half-filled orbitals. Also, if it is stable, if it is full-filled, only two conditions: half-filled or full-filled. Either it is not stable. What is it? Let's understand. Here it says ionization enthalpy of elements of group 16 is lower than group 15 due to half-filled p orbitals in group 15, which are more stable. However, ionization enthalpy decreases down the group. What is it? Let's understand it. Not a big deal. It just says in group 15, what is the general electronic configuration? NS2 and NP3. And in group 16, what is the general electronic configuration? NS2 and NP4. Now let's understand. Don't consider NS2, okay? Not just consider NP4 and NP3. In group 15, NP3 is there. It means in p orbitals 1, 2, and 3 electrons. And in group 16, in p orbitals, there is 1, 2, 3, and 4 electrons. Now it says 15th group element is more stable than 16. What is it? According to me and according to chemistry, if anyone is half filled, there is 6 element can reside in the group in actually p orbit. But there is 3, it means it is half filled. Okay, it is half filled right now. It is stable. If there will be 6 electron, 1, 2, 3, if there will be 6 electron, this is also stable. There is 3, it is stable. According to chemistry, if in any orbit there is no any half filled element or full filled, then it is not stable. It means here it is full 4. It is not half filled. Either it is not full filled. So it is not stable than group 15. It is okay? Okay, na? According to chemistry, what it says? It says, according to chemistry, if any orbit is fulfilled, it means if any orbit consisting 6, then it has to be 6, then it is stable. If any orbit can consist 6 and consisting 3, then it is also stable. 6 or 3, it is stable. But if any orbit consists 6, but it consisting right now only 1, 2, 3, 4, only 4, it is not stable. 5, it is also not stable. Only full feed and half feed it is stable, either it is not stable. Okay. Now next one, electron gain enthalpy. Oxygen has less negative electron gain enthalpy than S because of small size of 0. From S to PO, electron gain enthalpy become less negative to PO because of increase in atomic size. What it means? Electron gain enthalpy, what is it? It is nothing. It is just an amount. Electron gain enthalpy, it is actually a bag. You can assume it as a carry bag. If a carry bag is small, then it carry less number of goods, less number of items. If a carry bag is big, large, then it contains more number of items. What is it? Let's understand again. Assume this is your carry bag. This is your carry bag. Okay. This can consist one item, two item, three, four, five. Assume this is another carry bag of any another person. This is a big carry bag. Consists one, two, three, 4, 5, 6, 7, 8, 9, 10, 11, and 12 items. More number of items. It means what it means? It means if the carry bag is small, it can carry less number of items. If carry bag is small, it consists less number of items. If any carry bag is big, it can carry more number of items. Now it is oxygen and it is sulfur. In previous we also understand the number of electrons, atomic number of oxygen is less than the atomic number of sulfur. So the size of oxygen is less than the size of sulfur. So sulfur can contain more number of electrons and it can contain less number of electrons. So electron gain enthalpy of sulfur is more than the oxygen. Okay. Now electronegativity. Next to fluorine, oxygen has a highest electronegativity value amongst the element within the group. Electronegativity decreases with an increase in atomic number. Okay. This implies that metallic character increases from oxygen to polonium. Having it is actually the thing. Electronegativity. What is it? Electronegativity. You can understand easily. You know, oxygen highest electronegativity after the fluorine. Here it is. After fluorine, oxygen having highest electronegativity. It means it can react fastly. It can react more fast. And also electronegativity, if any elements having less electronegativity, it means it is metallic. Here it says oxygen having highest electronegativity, and as we go down in the group, as we go down, oxygen to sulfur, sulfur to selenium, selenium to tellurium, tellurium to polonium, electronegativity decreases. And as the electronegativity decreases, the metallic character increases. The metallic character increases. Electronegativity decreases, metallic character increases. Now in next class we will discuss physical property, chemical property and reactivity with hydrogen reactivity with oxygen, reactivity towards halogen, about dioxygen and its preparation and properties and its uses, about ozone and preparation. Thanks for listening.